So, in case of wait and stop and wait protocol, the sender will be sending the frame and waiting for the acknowledgement from the receiver. So, after receiving the acknowledgement, based on the acknowledgement, the sender will send the next frame or the same frame again repeatedly. So, this is what is happened in the case of stop and wait protocol. But in that case, lot of time is being wasted. For simple example, suppose if we are using the stop and wait protocol in this particular example, so frame 0 is being sent, that comes to receiver, then receiver will send the acknowledgement. So acknowledgement will be coming at this point. Now, the sender has to send frame 1 at this point. So frame 1 at this point, then frame 2 at this point, then frame 3, frame 4, frame 5. So instead of frame 8, frame 5 will be transmitted. So frame 5. That means, so how many units of time, if you take about each E1 is a 1 unit time. So 1, 2, 3, 4, 5, then about this is. So 16 units of time, so 5 frames. Every 3 units, 1 frame. So 5 frames will take about 15 time units. Okay, in 15 time units, so only 5 frames are being transmitted in case of stop and wait. But the same thing if you use go back and, so the performance is improved. At the same time, now more than 5 frames can be transmitted. So how it happens, we will see in this. So that is to improve the performance, the mainly for improvement in the performance, the go back and protocol is being used, because here the sender will not wait for the acknowledgement from the receiver before sending the next frame. So here they are going to keep on sending one after the other frames. Okay, so to improve the performance, that is the main idea in this. But of course, the resources required will be more. So more number of buffers are to be allocated. Only then this particular method is successful and will get the improved speed in this. How that we will take, we will just see how it happens. Now in this, go back and suppose sender, so upper line indicate the sender side and bottom line indicate the receiver. Okay, so this indicates the receiver state and this indicate the sender state. Now first sender is sending the frame 0, receiver is receiving frame 0 and receiver is acknowledging. But before waiting, the sender will send the next frame also. The next unit of time is send the next frame. Then during the next frame time, second frame, then third frame, fourth frame, likewise. So the sender is keep on sending the frames one after the other. Suppose the timeout is being given 7 units of time, for example. Okay, if 7 units of time is allocated for round trip time or timer, so the moment it started, sent the first frame, so timer will start. So by this time, the sender has to receive the acknowledgement for frame 0. If it is received, okay, fine. If not received, then it has to do something else. Okay, how it does, we will discuss. So supposed to be, that is, if the timer is started at this point for the frame 0, the timer will expire at this point. Okay, timer will expire at this point. So the acknowledgement 0 must arrive before this. So here the acknowledgement 0 is arrived at this point. So much earlier the timer, no problem. Okay. So we'll see some situation in this case. Now sender is sending frame 0. During the next frame time, frame 1. During next frame time, frame 2. Next frame 3, then frame 4, 5, 6, 7, 8. Likewise. And the receiver also receiving the frames one after the other. So frame 0, then frame 1, then frame 2, then frame 3 likewise. Now, so receiver has received frame 0 and frame 0 doesn't have any errors. So it is accepted, handed over to the network layer, and frame 0 acknowledgement is being sent back to the sender. During the next frame time, it has received frame 1. So frame 1 also, let us assume that no errors. So accepted, sent to the network layer, and acknowledgement is sent to the sender. During the next frame time, frame 2 is received, but frame 2 is having error. Okay. Now it is encountering an error with the frame 2. So as a result, what frame the receiver does, all the subsequent frames, so frame 3, 4, 5, 6, all of them are receiving, but they will be rejected, they will be discarded, because it wants the frame 2 first correctly received. Only then others will be accepted. So that is why all the subsequent frames will be discarded. And here in this particular case, so supposed to send the negative acknowledgement, but the protocol developed so is not using that. Simply the receiver is going to be idle in a sleep state, not going to receive anything till it receives again the second frame. So all others will be simply discarded. Maybe third, 4, 5, 6, 7, 8, all these frames might be received correctly, but the receiver is not bothered about it. Receiver is not bothered whether received correctly or not, but it want so that error frame must be received correctly first. Only then remaining things. Okay, so that is why it kept quiet. So after sending the second frame, it has started the timer. So by the time timer expires, it is keep on sending the subsequent frames. It's supposed to get the acknowledgement much before the timer expires for frame 2, but not received any acknowledgement till the timer expires. So acknowledgement for frame 2 is not received. So originally speaking, it has to receive the acknowledgement for frame 2 at this point immediately after the acknowledgement 1, but not received till the timer expires. Now the sender will think that there is something wrong. Maybe this frame 2 has not arrived at the receiver. So that is why it has not got the reply from receiver, nor feedback from the receiver. This is what the sender will assume, and after the time expires, again it is retransmitting the same frame. Retransmitting the same frame. Okay. Now this frame will be received by the receiver at this point. Now it is acknowledging. Till this time, whatever other frames have been received, all of them are discarded or rejected, because the receiver want to process them in a sequence and they wanted to be forwarded to the network layer in sequence. So that is the problem in this. Okay, so that is why all the subsequent frames are being discarded by the receiver only after receiving the error frame again correctly. Only then it is accepting the frames. From then it is accepting all the subsequent frames also if they don't have any errors. This is how the receiver is working. So but here what is happened? So it has continued 3 to 8. So 3 to 8 have already transmitted, but due to error with the 2, again it has to repeat from 2 onwards. It has to retransmit 2 onwards again. So this is the biggest disadvantage with this. Okay, this is a disadvantage. Unnecessarily retransmission. So now, 3 to 8 to be transmitted unnecessarily again. Anyway, 2 is having error, no problem, 2 can be transmitted. But 3 to 8, they might be received correctly, but the receiver is not bothered to check whether they are received correctly or not. It is not bothered. So as a result, so the sender has to retransmit frame number 3 to 8 in this particular example unnecessarily again. So that is a disadvantage which increases the traffic in the network. That increases the traffic in the network. So this is a biggest problem in this. Again from there onwards will be received without any problem. So this is one issue in this particular go back N. So here to happen this properly, now if sender has to send all these frames, means it has to allocate lot of buffers. It has to allocate lot of buffers because the moment frame 2 is received should be stored in the memory till it receives the positive acknowledgement. Then 3 should be stored in the memory till it receives the positive acknowledgement. 4 should be stored in the memory till it receives positive acknowledgement. Likewise, so whatever frames it has prepared at received from the network layer and prepared should be preserved in the memory or in the buffers. So those many buffers you should allocate. In this particular example, if you see, the frame number 2 should be maintained in the buffers till this point because it has received the acknowledgement at this 2 point. Okay, at this point. Now the buffer allocated for frame 2 can be removed and released. At this point, only at this point, the buffer allocated or buffers allocated for frame 2 can be released. Only at this time, the buffers allocated for frame 3 can be released because it has received the acknowledgement 3 at this point. Only at this point, the sender can release the buffers allocated for frame 3. Till now, the sender has to maintain the frame 3 in the buffers. So the memory requirement is increasing a lot. That is in case of, so go back N. But the advantage is performance. Right? So in previous, if it is stop and wait, so every frame needs 3 units of time for sending and getting back the acknowledgement. Only frame 1 can be sent at this point, getting an acknowledgement. Frame 2, getting an acknowledgement. Frame 3, getting an acknowledgement. Frame 4, acknowledgement. At this point, frame 5. Okay. So total how many units of time? So up to this 16 units of time. So 5 frames are being sent. 5 plus 0 is 1. So 6 frames are transmitted in 16 units of frame times. Okay. That is in case of stop and wait. But if you are using the go back N, now 8 frames are being transmitted. 8 plus 0, 9 frames are transmitted in 16 frame units time. Instead of 6, now 9 are transmitted means the performance of 3 frames is improved in this. Okay. So out of 17 frame times, so 10 frames, 9 plus 0. 0 is 1 frame. So 0 to 9, 10 frames are transmitted in 17 units of time. Okay. Whereas in case of stop and wait, in within 16 units of time, only 6 frames. Now 17 units of time, 10 frames. So that is the improvement in the performance. Okay, that is the improvement in the performance, but at a cost of additional buffers. So number of buffers are to be allocated in case of sender. Receiver need not. Receiver need not because the moment received, process it. If it is okay, send it to network layer. Then use the same buffer for the next frame. Process, send it to the network layer. Use it for the next frame. Likewise, if the next frame is error, discard all incoming, till it gets the same frame again. Once it is okay, send it to the network layer, release that, use for the next frame. So the receiver in this particular example, a receiver may not be allocating number of buffers, need not be allocating the number of buffers. So whatever number of buffers are allocated in case of stop and wait, the same number of buffers are sufficient in case of a receiver. But in case of transmitter, it's not sufficient to improve the performance. So the sender has to use more number of buffers to be allocated for storing all these frames, okay, at the data link layer point of the sender, so that till it can receive the acknowledgement for that particular frame. Once it receives the acknowledgement for that frame, then the buffers allocated for the frame can be released, and those buffers can be allocated for some other frame. Likewise, okay, likewise, so it has to happen. This is how the Go backend is improving the performance at the cost of additional buffers. Okay, so this is one method. The next is to improve the performance further, to increase the performance further. So the next method, next protocol, selective repeat is being derived. So in that case, even the receiver also will be allocating number of buffers. Okay, so because now see, in this particular case, instead of discarding them, if receiver is capable of storing them and if they are okay, why can't the receiver retain it to reduce the unnecessary movement in the network? Okay, so unnecessary movement in the network can be eliminated if these frames, if they are okay, these frames are being stored in the receiver's buffers, in the data link layer itself. Okay, then the performance can be further improved by thinking this in this direction. The next version of the protocol with the name selective repeat is being given. Okay, we'll see by using the same 17 units of frame times. So how much data can be, or how many frames can be transmitted, that we will see.